packet pushers.
Hey, everybody, and welcome to this week's episode of Packet Protector, the podcast at the intersection of networking and security. It's JJ here with Drew, and today we're talking to a friend, Mike Holcomb. Mike is the Fellow of Cybersecurity and ICS OT Cybersecurity Global Lead at Fluor, and he's worked in some of the world's largest ICS and OT environments. I personally share a lot of his stuff on LinkedIn. He has a lot of resources, free training, and ebooks for people both on operational technology and the IT side who are tasked with securing these environments and just to get more familiar. So, Drew, what do you think about this topic before we dive in?
What I learned from our conversation is that OT is pretty serious. It's like the physical world where if things go wrong, things could explode. So if you're an IT person who is coming into an OT environment for the first time and being tasked with protecting it, there are things you need to know. And Mike does a really good job of telling us what we need to know, but also making it not so scary for an IT person coming into this new environment to be like, oh yeah, I know what I'm doing here. I can figure this out.
Very approachable. And Drew's very intent on the idea of blowing things up today. I don't know what's going on. He's very fixated on explosions.
Mike brought it up, so I ran with it.
Yeah, you did. Well, let's get started with Mike. Hey, Mike. Well, welcome to Packet Protector. We're going to jump right in. And one of the things I think people are going to notice about you when they look at your profile, various places, that you do have a history in technology. You've done sysadmin work, network engineering, security. So how exactly did you stumble into the world of OT and ICS, or was that intentional?
Totally stumbled onto it. I have been a computer nerd since day one. Also had really a fascination from a security aspect, even really before cybersecurity was a thing. So I've always either worked in IT, worked in cybersecurity, I think 30 years at this point in cyber. And then always talk about Stuxnet as my first interest into the ICS OT world, even though that was 2010. Even though the more I think about it, 1995 was actually when the movie Hackers came out. And I think a lot of people are familiar with the movie, right?
Mm-hmm.
Yep.
And Zero Cool and Acid Burn and all the others. And not only was it a cybersecurity movie, but when you really think about it, it's more OT than kind of the IT side of the house. So it was all about hacking building management systems, right? To turn on the fire suppression or the sprinklers. And at the very end of the movie where they turn up the lights to say like crash and burn across the buildings. Zero Cool was hacking the TV station right at the beginning of the movie using computers to control something physically in the real world. So he was taking control of those systems that were, of course, back in the day, manually taking those old VHS tapes and putting them into a machine to play on the TV channel.
Oh, VHS.
Yeah, I think that's probably actually where it really started.
Okay.
But I think more formally, yeah, when Stuxnet came out in 2010, for those that aren't familiar, Stuxnet was when the Israeli and American states had used a cyber weapon to infiltrate a facility in Iran that was being used to ultimately create nuclear weapons. So at that facility in Natanz, they had nuclear centrifuges that were used to enrich uranium gas that could be used to create bombs. And so the government had thought we can drop bombs on the facility and kill civilians and potentially cause some type of other issues. And we prefer not to do that. Why don't we take a cyber approach? And that was when they developed Stuxnet, went in and over time had destroyed significant numbers of those centrifuges over months to the point where we probably set back the Iranian nuclear program 4, 5, 6 years, depending on who you talk to. But I was really fascinated because one, it was a technological marvel from just a cybersecurity perspective, right? It had 4 Windows 0 days and the way it moved through the environment, took control over the Windows systems, which in turn were used to control the controllers that were responsible for moving the centrifuges, right?
Mm-hmm.
Spinning them up and making sure that they did what they needed to enrich the uranium. And I could go on.
Well, and that was really the first kind of OT-ICS specific formation of, at least that I knew of, something actually targeting that system in that way with purpose-built specific tools, which was kind of interesting. And I think it was pretty well documented. There's 2 books I always get the titles of mixed up, but one of them covers, is it Command and Control? It's Conceal and something.
That one I might not be familiar with.
Yeah, but they covered the Stuxnet situation in the book, which was pretty interesting because I came from a military intel family, and the transparency with which they communicated some of this afterwards was intriguing to me.
Right. Well, like anything that gets communicated out from the military and the government, it's always interesting how things evolve over time. But yeah, there are two books that I always suggest. So Kim Zetter wrote a book called 0 Day. The title's much longer, and it's completely dedicated to Stuxnet. And then the best book, not just for Stuxnet, but just OT cybersecurity in general, is Sandworm. That was written by Andy Greenberg, who's a writer for Wired magazine, and it focuses on the Russian state actor group called Sandworm. And they are the most prolific group in targeting OT ICS environments. They're responsible for the majority of the main incidents that we've had over the years. And they are very much responsible for many of the actions that we see today between Russia and Ukraine, and a lot of the OT related attacks like power outages with the grid. And most recently, where the heating was turned off in 600 apartment buildings in the middle of winter for 2 days with sub-zero temperatures.
Russia gets a little nasty when it comes to the offensive side of things, I think.
Especially when the Ukraine's involved, unfortunately, for the Ukrainians. But
So Stuxnet came out and you thought, yeah, I want to be in that environment. Was it like, oh, that's cool, I want to learn more about it? Or, oh, yeah, that's cool, we did that. And that could also probably happen to us.
there was a couple of things. It was a perfect kind of storm of one that it just made me start wondering, like, well, how does this work in a power plant? Because and that's when people were starting to talk about the Russians can take down the grid in the United States. Like, no, not really. That's not how it works. But okay, I didn't know better back then. And then at the same time, Siemens had devices that were targeted with Stuxnet, and I worked next door to Siemens, and I don't know, there was just that connection that made it interesting. But yeah, it was really just asking those questions about, like, how does this work in water, in power? And I had friends that kind of worked in and around those different fields. And so I started asking questions or get connected with the people I could ask those questions. And nobody wanted to have those conversations. And this was in like 2010, 2011. And people were really either mean or nasty or just very short. And I think I realized that they didn't want to have those conversations because they weren't doing anything about cybersecurity. Right? They didn't want to have those conversations.
Total like security by obscurity in the utilities sector and telecom sector, I think, for decades, which was, well, that's not going to happen because nobody knows how to do it except for us, and we would never do that. That was like the drum, even when you could Google, like, or Alta Vista, whatever we were doing back in the day, right? Like the information was there.
Exactly. And so you're dead on, security through obscurity, which of course we always say never works, but it's worked for OT for decades and decades. And that's changed the last 4 or 5-ish years. It's no longer the case.
So Mike, I'm going to put you on a spot. You brought up Hackers movie and you were talking about like the facilities management and the lighting and then this and that. But we've had a lot of buzz and conversations, especially around, different engineers in different circles around where is the line between OT, operational technology, and IT and IoT. So I'm kind of curious about, like, what are your thoughts on that? I don't think there's a hard and fast rule written anywhere, but where do you draw the line?
Yeah, for me, there's 2 main camps. I think overall, I am more in the camp. To me, if it's on the OT network, right? If I have, let's say, a power plant, right? If you go to a power plant facility, right, you have the plant itself that generates electricity, and then you have the back office, the IT network. And then there's a connection between those two. And that might be very secure or it might not be secure at all. But you have basically that IT network and you have that OT network. If something's in the OT network, I just consider it OT. If it's an IT, it's an IT. There's usually a DMZ between the two. So we just talk about the IT/OT DMZ. And I would consider those OT assets as well, just from the perspective of where they reside. A lot of people will say, and a lot of people don't realize, if you go into an OT environment like a power plant, there's a ton of Windows systems.
Yeah.
There are servers, there's Active Directory, there's Windows workstations, and the list goes on and on. So there's Windows everywhere. So a lot of people might say, well, that's not a OT asset, right? That's just a Windows server or it's a Windows workstation. When they think OT assets, they're thinking more like programmable logic controllers or PLCs or HMIs, which are human machine interfaces, which we use to control those PLCs that control things in the real world. And so, yeah, there's the 2 camps. I'm more of a, hey, if it's in the OT network, right, then it's an OT asset because typically you'll have an OT team that's responsible for protecting it.
So you're saying a Windows machine could be on an OT network. So even though it's Windows, which we'd commonly put in the IT bucket, you see it as OT because it's connected to an OT system.
Exactly. That's just the way I look at it. I know there's people in the ICS world that cringe when I say that, but to me, it's who's responsible, especially for protecting it. And a lot of times you'll have an OT team. Now, sometimes it's IT that's protecting it, but depending, again, on more where it resides and which network, that's how I label it.
What about this do you see sort of a protocol boundary separating IT and OT?
We almost always, thankfully, have, if you go using the power plant example, if you go into that power plant, you have the plant network in OT, and then you have the back office in IT. Mm-hmm. That you'll have that DMZ between the two that you can use to control the flow of traffic. And so the best way to protect your OT environment is to never allow IT to reach into the OT network. Now, you only want the OT network to be able to send to IT. Hopefully that makes sense. So you want one-way communication. So if I have a power plant, right, I need to get certain data from the power plant to the back office so they can do things like understand from a business perspective, how much electricity have we generated, right? How much are we going to be able to bill, right? How much in resources have we used to generate that electricity, right? They have to pay their own bills. Or if I have a manufacturing plant, right, it's how much insulin injections have we manufactured, right? Because the back office is responsible for doing things like scheduling and shipping and logistics. They need that data from OT. So if you can only have OT send in one-way fashion to IT, right there you've reduced the vast majority of your risk because most of your attacks against the OT network are coming from the IT side of the house, right? Because that's where you have users sitting there browsing the internet, reading emails, right? Clicking on links that they shouldn't, or open up malicious attachments to infect their system. And once attackers are in the IT network, which we know they're going to get there eventually, that it's usually a fairly quick amount of time before they can pivot or transition from IT into OT if that path exists.
Yeah, I mean, I know that's why in best practices, we have all of the party lines of, the segmentation, the unidirectional communication, completely separating the Active Directory infrastructures and the data paths. But I think in utilities, you've seen a lot more, but the little bit that I've worked in over the years, they do a relatively good job there. But then as you start to slide into, I think, some of the other industries like manufacturing.
Manufacturing is the big one.
Manufacturing is all over the place because you've got pharma all the way down to, aggregate. But it seems like that's a huge sliding scale of, definitely I've dealt with clients and requests coming in where there is no segmentation between IT and OT, and there's not that knowledge. And I think now one of the reasons we were really excited to have you today is a lot of the IT teams and the CISOs who've traditionally been responsible for IT are now being voluntold to manage the security for OT, but we don't do the same things from a security policy perspective, both places. So we wanted to dig into that with you. So I am curious, I'm going to poke a little bit more into this, knowing that we have other digital transformation and things happening. Where is that IoT boundary for you as it relates to OT?
So we talk about IoT usually. So I think, traditional IoT, right? Internet of Things. So you have a device usually on the consumer side that needs internet connectivity to function, right? Because it needs the cloud power to get its functionality. When we translate that to the OT world, that's where we typically talk about IIoT, or the Industrial Internet of Things, which is a term that GE had coined. But they had some great use cases where, let's say you have a locomotive, and on that locomotive, you want to line it with potentially thousands of sensors so you can understand how it's performing. You can do things like predictive analytics and understand when parts need to get replaced proactively. And so you could have all that data. Now, you can't have a server farm sitting on that locomotive, right? You have to be able to take that data and send it up to the cloud where you can have that server farm to crunch the numbers to do things like predictive analytics. And so that's where, IIoT really comes into place. And that's great. It's another one of those where completely understand the business case. Let's just make sure we do it securely. So it's another one. let's force it one-way communication. Just like if we were doing, like, think EDR in an OT environment, right? We talked about we have all these Windows systems everywhere in OT. Well, I want EDR running on those so I get better visibility and understand what's happening on those systems. But do I want to allow that data to go out and then communication to come back in? Like, no, I don't. Because we know every cloud environment out there is going to get compromised at some point. And that would just allow an attacker to come right into the OT environment. The only time I heard of a great business case, I had a conversation, I'm like, I never want to, hear about somebody, doing operations from the cloud, right? They're talking about, wanting to control a power plant from the cloud. And I was like, the risk there is so tremendous because, again, the cloud environment is going to get compromised eventually one day. And then you're giving the attacker the ability to control your power plant. And they said, well, it was actually for the Ukraine. And they have a great business case because their control or their operation centers could literally be bombed and no longer exist.
Right. There's a bigger risk profile that they're dealing with.
Right, exactly. So I was like, I can understand it in that situation. So I say, have it as a backup connection if you need it, but it's not something that I would definitely have on 24/7 or ever rely on.
Speaking of, separating OT or ICS and IT, in my mind, it's always been like IT's dealing with things that have IP addresses and maybe speak Ethernet or IP, but OT is a separate set of protocols. Is that the case still, or are those boundaries blurring?
Definitely blurred for sure, if not more. You see more IP anything in ICS OT these days. You still see, especially in older environments where IP might not exist or it's just been recently introduced, they have older protocols like Modbus is one of the most commonly used protocols in ICS. So you see it everywhere. But then we also have a version of Modbus that runs over TCP/IP, right? So now we see not only IP addresses on pretty much everything in ICS and OT, except in really old environments, but we also see these protocols that run on top of TCP/IP. The bad thing about that from a security perspective is that these protocols were written decades ago where security, of course, was never thought of. And so many of these protocols have so many inherent weaknesses and vulnerabilities. Like Modbus is an unauthenticated protocol. You can reach out to a controller running Modbus and you can essentially tell it to do anything you want. So that was how the Russians, in part, when they went into those apartment buildings in the Ukraine in the middle of winter and they turned the heating off for 2 days. All they had to do was go in using Modbus and basically tell it, oh, you think the temperature is like 68 degrees inside the building, but make it think that it's always 68 degrees inside, but then they drop it down to nothing. So essentially it turns the heat off. So the system always thinks it's warm inside the building when really the heat's off and everybody's freezing inside. So yeah, you have all these inherent security weaknesses in those older protocols. And then sometimes you just see the older protocols. The other problem is it was written by, everybody always jokes, but it's usually some old guy named Bob that had written this protocol 30 years ago. Bob probably is no longer around for whatever reason, right? And you literally are pulling out Wireshark, trying to do packet captures to understand, right, how that protocol works and how it, and maybe like in the power plant example, right? How do you use it to control power generation?
Maybe we could have like a seance and raise Bob the dead guy and communicate with him.
Get the Ouija board out.
Through a medium. Yeah, so there's still legacy stuff. There's unauthenticated protocols. What do you think are the most common vulnerabilities in these environments?
The couple of big ones we've already touched on. Again, unauthenticated protocols. For me, that's probably the worst. It's just one of those that a lot of people in OT, especially engineers, right? They just don't realize the risk that's there. And I've had conversations even with CISOs and folks that control some of the world's largest control system environments, and they don't realize that those controllers are vulnerable. And they're just like any other type of system out there. They have a processor, they have memory, They have little hard drive space, usually much smaller than we have in PCs and servers because they're not storing massive, databases and spreadsheets. But they have a network connection, the IP address that we're talking about. They run services. They have vulnerabilities, right? They run code.
I'm assuming, though, Mike, people would argue that they would say, well, in this closed, ideally segmented environment, we can talk about that in a minute. But the argument would be, okay, we have, especially in utilities, in certain utilities, there's tight physical controls. You'd have to be in the space. You'd have to jump through all of these flaming hoops to get network adjacency into that. What is the rebuttal for that, if that's what somebody's thinking?
And I would say that's great if you work in one of those environments. Like in my day job, we do some government work. We now run the facility where the United States builds nuclear bombs. That would be very true for that environment. You have to be in a very particular specific position physically to be able to have an impact on a particular system. And then that it's isolated from every other system. Those environments are very, 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 very few and far between. So typically what you'll see is most environments think they're secure. They think they might be air gapped, right? They're not connected to anything else. So they're definitely not connected to the internet. And then, of course, they find out otherwise.
Air gap is like the tooth fairy.
Right? Exactly. I always use the example, and this goes back even before Stuxnet, where the Davis-Besse power plant had been compromised by SQL Slammer, right? So you had SQL Slammer running around the internet back in the day, infecting all the Windows systems running SQL Server that weren't patched. And I was like, well, this is a power plant. Like, how did it get infected? And they thought, well, we're air gapped, right? And so they found out that the contractor that was responsible for what they call the data historians. So those are typically just Windows servers that run Microsoft SQL Server. They're just databases that store essentially usually performance data of what's going on in the environment. And that's where you get data for things like predictive analytics. And so you're storing that data. Well, the contractors responsible for those systems, they ran a T1 line. So a data line, for those of you that are old enough to remember.
This podcast is really showing all our ages, I have to say.
If you're of a certain vintage, you know what a T1 line is.
So they have this data line run from inside the plant to their office. So when their office got infected with SQL Slammer, of course, the worm just comes right in over that data line and takes out those data historians. And the kicker was that was a nuclear power plant. So it wasn't just a regular oil or coal. That was a little bit concerning. So I always go back to that. And you just see that today. Dragos, which for those of you not familiar, they're kind of the big ICS OT cybersecurity shop. I liken them a lot to Mandiant, right? Because we always say in the IT world, if you get compromised, you're going to call Mandiant, right? They're your first call. Dragos is going to be your first call in the OT world. And then if they can't get to you, you'll call Mandiant. But you go to Dragos and they every year release their year in review report. I think it was the one last year that they were talking about out of all their engagements. They do incident response and pen testing and the list goes on and on. But where they go in, and it was like 70% of environments that thought they were air gapped or that they were at least segmented properly weren't. 70%. So there's a lot of folks out there thinking that they're probably secure, but
yeah, some of the numbers out of those reports were pretty staggering. I don't remember if it was last year or the year before, but they came out with a remote connection bubble diagram. So the bigger the bubble, the more of something there was. And, it was like some percentage of sites had, at least one connection, but actually the bulk of them had 3, 4 or more. And then they started picking apart like protocols, a lot of unencrypted protocols, egressing right in and out through that network link. Yeah, it's a little bit disturbing because I don't think people know. I do feel like I have to add a little caveat to incident response in calling, Dragos or any company. And that's that if you're responsible for these environments, you want to connect with these people before there's an incident.
Right.
So if you don't have a plan, if you're managing IT security or you're involved in that, part of what you need to be doing in incident response is creating those connections early before there's an incident so that they have some visibility and understanding of your environment before you're in a situation where you're trying to, do forensics.
Yeah, and the big one I found out as well, working with them over the years is just having the retainer in place because then you have all the paperwork out of the way. Because if you're in a breach, you don't want to have to wait weeks for the lawyers, right, to finalize a NDA or, the contracts.
And you also don't want to use an IT security company in an OT incident response. I think that's probably, Mike, you'd back that up with two thumbs.
Completely. Yeah. And that's why Dragos is great to work with. Mandiant, they have a great OT team as well. So they're definitely known as an IT shop, but they also have a great OT presence as well. And there's others out there, but the shops that I would count on in that type of situation, I could count on one hand. Yeah. Because most of the others are typically traditional IT shops that are just moving into the OT world, and they just don't have that experience.
So, quick observation before I hit my next question, referencing back to our conversation about old industrial control system protocols being written by guys named Bob 30 years ago. I will note on the IT side that Ethernet was written by a guy named Bob 40 years ago, so we can't be too smug either.
Right.
It's a persistent issue. So if I'm, a traditional IT person, an IT organization, and I'm now finding OT or ICS falling under my purview or being asked to work with an OT team, where do I start? Like I assume as a traditional IT person, I'd be thinking about, well, let's start with inventory. What do I have? What's its posture? What are the risks, et cetera? Or is there somewhere else to start? How do I go about thinking about this new environment?
Yeah, no, that's a great place to start. I would say, one thing for everybody to keep in mind is when you look at IT and OT, and a lot of people in the ICS OT space, they'll tell you, they're nothing alike, and IT and OT, IT security is not OT security or vice versa. And at the same time, it's really, I like seeing it the other way around. I want to focus on IT and OT have so much more in common than we don't, right? Where we are different, things like vulnerability management, right? We need to understand how they are different and then work within those confines. Because in the OT world, we most importantly, our number one priority is always ensuring physical safety. We want to make sure everybody goes home at the end of the day.
We always talk about cyber physical assets, right?
Right.
Because, an email doesn't get delivered, or like literally a physical machine or system controlling something in the world is at risk of being impacted, which is very different than what we do in IT.
Exactly. Cyber physical systems, which is another term. It's just another way of saying OT, another term that Gartner came up with. So it was like, thanks. We finally got everybody agreeing on OT. And now we're introducing another. Rob Lee, who's one of the gentlemen that founded Dragos, he talks about OT as IT plus physics, right? And that's a great way to think about it, right? Because we have a system, a computer, right? You can call it a controller or a PLC. It's a computer that's just used to control something moving out in the real world. Or I talk about, what if it's just my thermostat at home is a controller, and if it gets too warm, right, it sends an electrical signal down a line to the air conditioning unit to turn it on. And then when the temperature gets back to the correct temperature inside, it sends another signal to turn off the air conditioning unit, right? And it doesn't matter if it's an air conditioning unit or it's a 5-story tall generator that we're using to create electricity. The basics work exactly the same, believe it or not.
But when you're talking about physical safety, I mean, like someone might say, oh, I blew up our data center today, meaning they had a networking incident. Whereas in your environment, you could say blowing something up has an entirely different meaning. It's like literal, like when you're talking about an oil refinery, that could be literal. So you're talking about like, we want to make sure people aren't hurt by, a valve opening and oil gushing out or a fire starting or whatever. Is that what you're talking about?
Exactly. And that's a great example. And that's where cybersecurity really comes into play, because you don't want an attacker to be able to come in and manipulate the environment to cause some type of destruction, whether it's to take out part of a facility and they just want to bring that facility down, or their goal is to kill people. So, and that was highlighted in 2017. We have the Trident incident where the Russian state, the sandworm team that we were talking about earlier, had gained full control over a petrochemical facility in the Middle East. And talking about Rob Lee again, he attests to the fact that the only reason they were positioned and they had taken full control over what they call the safety instrumented systems, or the SIS. And the SIS is your fail-safe system for safety. So if there's ever a condition in the plant that's going to cause some type of safety issue, it's going to shut down the plant nicely, right? Nobody gets hurt. There's no damage to the environment. Plant doesn't get damaged, and we can go get the plant back up and running and life gets back to normal. So the only reason an attacker would take control over the SIS, especially full control like the attackers had done back in 2017 was to kill people. That's the only reason that you would take control over it. And it was another one where those SIS systems, they should be fully air gapped and segmented, but they weren't. There was a very flat network, and the attackers got in and had control over that. So it's one of those where it just highlights another aspect of concern, and where OT can be very different than IT. Again, I still go back to, we have so much more in common. It's just we have to realize where things are different.
I mean, it seems like a really critical thing I'm taking away is that segmentation, air gapping, some way to separate, unidirectional communication. Are there tools that I can like plug into a network and like just on a regular network, I'd start doing discovery to see what responds to a ping? Are there similar things that happen on the OT side to actually confirm, yeah, this is air gapped, or how does all that work?
Yeah, it's just like in IT. Believe it or not, I remember the very first project I stepped foot on, and this is 10 years ago, was actually a power plant. That's why I always use it as examples.
Mm-hmm.
And one of the largest power plants we have in the Western Hemisphere. Step on site, and the engineers, they're actually using Wireshark. I was all worried I'd be coming in and be talking about things and using tools that, were way over my head. I'm like, we're using Wireshark. Oh, you're talking my language. So I could sit there, and they were actually trying to troubleshoot a wireless bridge between the plant and basically this controller that was like a couple hundred yards away, that was basically a water pump where they brought in water into the power plant for things like cooling and generating steam. So we worked on that for a couple hours, and it was the best thing because we were best buddies after that like little exercise. And then I could have my full run of the facility, and they were showing me and taking me all around and showing me everything. So it was really cool. So it's very similar, just like in IT, right? The network is the same for all intents and purposes. So it's, you want to find a span port or, mirrored ports to be able to get an idea of seeing the traffic. Wireshark is still not only in IT, but in OT, right? The undisputed champion of being able to not only sniff packets, but also having those parsers for all of the common ICS OT protocols. And not just the ones that run over IP, but the older versions that aren't IP based. And so it has a lot of those parsers that are built in to be able to show you what you need to see to be able to understand what's happening in the environment. So it's just like in IT. The first thing I would want to look at is that OTDMZ traffic and make sure I don't see any internet traffic coming in and out of my OT network, right? But it happens.
Or publicly routable IP addresses inside the network.
Right. Well, and I've seen that a couple of times. I just did a free OSINT for ICS OT course. And one of the examples we found on the internet was, somebody had put too much information in screenshots on LinkedIn, and it actually showed their controller, and the controller had a public IP address, probably sitting on the inside of their network was that the public IP address, because
easier to reach that way.
Right, exactly.
As you were talking, I was just thinking, I'm about to show my age. So a long time ago, some of the government clients I work with used a tool called, I think it was called Lumeta. And it was specifically designed to, like, you could kind of put it places and it would have reflectors up out in the internet in the cloud.
Yeah.
And so it would start doing things in a way that would eventually ping traffic around and get out of whatever network it was in. So it would follow routes, right, and gateways.
Sure.
For the purpose of understanding where those ingress and egress points were. It's like somebody dropped a T1 or somebody dropped a this or whatever. And it looks like, Drew, we might have to do a little digging in this another day, but it looks like Firemon picked that up, and it's their cyber asset management tool, which it claims works with OT in addition to other environments. You got to be careful with what you play around with.
Yeah, we have to be very careful when we talk about introducing traffic into an OT environment. Now, this is more true in older environments, but still, you always go back to remember the number one priority being safety, right? If safety is ever at question, which is always going to be, it's like, can you introduce new traffic into an OT environment that couldn't potentially cause some type of situation? Say if there was an explosion, right? Because it could happen. Do we want to take that risk? Or even just if we take down the plant, it's going to cost the business $5,000 a day or $50 million a day, right? Depending on the plant. Is the risk worth it? for me, it's never going to be worth it. So doing things like finding those routes, or when we talk about finding assets, kind of going back to Drew's, earlier question, where do we start? One of the things is, understanding what you have in the environment, just like IT, right? We can't protect what we don't know we don't have. And so in IT, though, we just sit there, we blast away with maybe NMAP or Tenable, right, to define what's out there, maybe look for vulnerabilities. And we don't have that option in OT because there's always that risk that we could cause an issue.
Mike, I got to ask you about this because I trust your judgment here. I sat on a webinar a day or two ago where, someone was talking about, they work in OT and ICS, and they were talking about how they did like a few tests across just a couple of specific PLCs. One was a Phoenix and a Siemens and something else. And like basically this tool, that tool, NMAP for OT, NMAP regular, and then some other vulnerability scanner. And there was one instance, I think with the Siemens PLC they were using in the lab, that it had some slowdowns in processing. The scan time took longer. But the message that I heard, I had to hop off, but what I was hearing is, don't be afraid of using regular tools. It might slow the scan down, but it doesn't impact the device. The CPU utilization doesn't go up. I'm in the opposite boat with that because I have accidentally bricked things on the IT side with NMAP.
Right? We all have.
I know some of the, at least my limited exposure is a lot of the OT stuff does not respond well to malformed packets, open sessions, things like that. What is your take? Because I would rather send your message out to the world.
Yeah, I'm in your camp, especially when it comes to those. It goes to one of the earlier question, but the traditional OT assets like the controllers, the HMIs. We talked about those safety instrumented systems, right? Do you want your safety instrumented systems impacted, by slowness in any stretch of the imagination? No. And in OT environments, you need real-time communication to be able to move things in the real world safely. And so if you ever talk about introducing any type of slowness, you're going to introduce an issue, which is going to cause a problem. Maybe that takes down production. Maybe it creates a safety issue. Maybe it kills somebody, right? That's where you start thinking. So when we talk about scanning in OT, that's where we don't. You can't, because you are going to introduce those issues. Like you mentioned, especially the older control systems, they don't still understand a lot of the packets that they receive from like a tool like NMAP or from Tenable, right? You're just throwing, in some respects, just a lot of probes or a lot of garbage at times too at these systems. They don't understand. And a lot of the older ones, they would just crash. I actually had a CISO for a very large environment in the US. He told me that he had a controller in a network that if you scanned it with NMAP, and he was completely dead serious, maybe a bad expression, but he said, if you scan this controller with NMAP, it would leave a crater in the ground 3 miles wide. Ooh. Completely serious. They manufactured a specific type of, let's say, fuel. And okay.
So how on earth then do you do a device inventory in that kind of sensitive environment?
There's a couple of options. So active scanning is an option, right? And if you had like maybe a small environment, like I have some small clients on the side outside of my day job, like in manufacturing, right? Manufacturing huge in the Carolinas where we're at, that, active scanning might be acceptable, especially in a newer environment with newer equipment. But even then, right, I still would want to do it. So you can look at passive gathering, right? Taking network captures if you have that visibility to be able to then dissect the packet captures, right? So I've been doing a lot of work with that and creating like parsers with ChatGPT to go through PCAPs and build out an asset inventory based off of what it's finding in PCAPs. That's an option. But I also think of it also as like playing Sudoku, where, you have like the page and you have some of the numbers and then you have to fill in the rest. And that's like building this asset inventory, or what we call asset registers in OT. Again, it's asset inventory. So yeah, you can do active scanning, or I should say that's an option. I wouldn't. There's passive gathering, passive sniffing. There's the option to walk the environment, right? You're literally tracing cables. In the OT world, that can be very dangerous. Even if you just bump something, you're tracing cables, that could result in a significant safety issue. So that's not something that we would want to do, but it's another one. It's an option. Another one is you can look at all of your existing documentation. And if you have network diagrams that you could pull from, or you have like your controller programming documentation and code that might have some of that information. So really, there's not a great answer where you can go to one place and say, here it is, right? And you can't just sit there and blast away with NMAP or Nessus. And you have to pull from all these different places and play Sudoku to kind of really build that wonderful Excel spreadsheet that everybody still uses today to maintain their asset register.
And that counts.
Right?
It's sort of a joke that today you finish a network diagram and it's immediately out of date. Does that also apply in OT environments, or because they change less and are more stable, they may be a little more up to date?
It's much less, thankfully, in OT. And that's also, think of it from a defensive perspective. Going back to mentioning with Rob Lee, one of his most common sayings is defense is doable in OT particular. And part of the reason is OT environments are very static. So you might have a system that goes down and you need to replace it. So you might have a change in the MAC address, or maybe a firmware version on an asset is slightly different, but the vast majority of your network and the systems and the IP addresses and the MAC addresses that we're looking for, they're always staying the same. And so it's much easier, especially if you're doing things like network security monitoring, which less than 5% of OT environments globally are. But if you are doing things like network security monitoring, it makes your job so much easier, right? To be able to understand and watch, right? What's going on in the environment. In OT environments, there's really little communication. And the communication you do see, it's very repetitive. So if you see something that, whoa, I haven't seen that in 6 months, something's going on and you need to investigate and take it very seriously.
I know we're coming up on time and I want to make sure, Mike, you do a lot of amazing things for the community. So you've got a lot of free training resources and videos. I do want to let you share a little bit about that with everybody so they know what to look for and where to look for it and where to start. So probably the first question here is, if there's someone listening who is coming kind of from sysadmin networking side or security architecture on the IT side, and they're interested either out of curiosity or they're being told to deal with some of this, what are some key things for them to learn first? And then kind of maybe segue that into what are some of the resources you've provided for people?
Sure. Yeah. And I actually have an ebook. There's actually 2 ebooks that I have that I put together to answer that exact question. So if you're coming from an IT background, there's an ebook that talks about 10 steps. And then there's a version if you're actually coming from an OT background. So if you're an engineer or maybe you're a PLC tech, right? You're programming controllers. But yeah, you want to start being able to learn to think like an engineer, number one. That was probably the first thing that I had to learn. And once I did that, OT opened up for me. Part of that was being able to connect with engineers, but also understand how the environments are put together, which really gets into the second part, which is understanding OT is just like anything else. I came from an IT background, again, 20 plus years in IT cybersecurity before getting into OT. And I remember hearing PLC and HMI and SIS and DCS and like, what? Just being really intimidated. But it's just like, back in the day when it was, I heard TCP IP or UDP, right? It's just like the same thing. So, I would encourage people, if you're interested, don't be afraid and hopefully don't be frustrated. That's why I put together the content that I have, because I remember how frustrated I was trying to get into ICS OT cybersecurity back in the day. And so that's why I put the ebooks together to help people walk through that process. Or I put together the YouTube courses. So there's one course that's over 25 hours, which is, getting started in ICS OT cybersecurity. And you actually went through the class.
I went through, I think, your first one, and it was really awesome. Such great information.
Yeah, so I had updated that and put it out on YouTube. And I think there's like 33,000 views on the first part, which is really cool to see. And I get a lot of great feedback, which is really exciting. And then we just did the OSINT for ICS OT course as well. So, how does OSINT apply to control system environments? And so half of that is up on YouTube right now. And then I'm just getting the rest out.
Yeah, because, posting your console view and screenshot in LinkedIn with a public routable IP address is probably not so good.
Yeah. And ever since I taught that class, I just keep seeing even more examples that I couldn't even share in class. They're that bad. Yeah. Where people have like entire network diagrams for their customers, which is really, really scary. But yeah, I would say first place, if people are interested, you can find me on LinkedIn, right? Mike Holcomb, just / Mike Holcomb. On LinkedIn, I post Monday through Friday at 11 a.m. Eastern every day, all ICS OT content, learning, how to get involved, how to get into the field. Feel free to reach out, connect, ping me if you have any questions. And then you'll see all my other resources. I have a newsletter, which has about 3,800 people on it now, which is kind of scary. And then the YouTube channel, if you look up, probably the easiest thing is do getting started in ICS or OT cybersecurity, and you'll see it. So you'll see the course there as well. Those are really the two main resources. And then I have some other things around that, but LinkedIn and YouTube, those are my two main channels for getting the content out. And over probably I'm about a month away from having the Intro to ICS OT pen testing course, which I'm having a lot of fun put together. So yeah, I think a lot of people are really interested in, how does pen testing work in ICS OT? And it's just like everything else we talked about, just to stress for everybody as we wrap up, IT and OT have so many things in common. I'd say probably 80-85% similar. It's just that 10-15%, like we're talking about with, I just can't spin up NMAP or Nessus and just scan away in an OT environment without potentially killing somebody. That sounds extreme, but that's very realistic in a lot of these environments. Yeah. So it's very important, and this Drew, your earlier question, where do you start if you're coming from IT or you're managing or you're responsible now all of a sudden for OT environments? It is learning those differences. And I would say one of the best places is that YouTube course that I put together. And there's other great training out there, but there's significant cost. Best class I've ever taken in my life is Rob Lee's grid course at SANS. It's $10,000. So,
which is cheap by SANS standard.
And hey, to be in the same room with Rob Lee, who, for most can be considered like the thought leader in ICS OT cybersecurity today, it's worth every penny. But most of us don't have like 10,000 in our own pocket, to go take that course. I'm very fortunate that I work for a company that does send me to those classes, and that kind of allows me in turn to share that with everybody else. Not that I'm taking SANS, data and sharing it with everybody. Just saying.
Awesome. Well, we have all of the resources linked in the show notes for everybody, the book, the YouTube, LinkedIn, everything. Just want to thank you again so much for joining us today, but also everything you put out there for the community for free. It's really helpful. I love reading and sharing it with everybody.
Yeah, no, thanks for the invite. I really appreciate it. I had fun sitting down and talking and sharing with everybody. So thank you again.
Yeah, Mike, thanks for joining us. And thanks to you, the listener, for listening to another episode of Packet Protector. If you've got a topic you want us to cover, you can find JJ and I on LinkedIn at packetpushers.net or at packetpushers.net/community, where you can join our free Slack channel with other IT and security pros. If you've got a comment, a correction, or a question, you can reach out to us at packetpushers.net/FU. The FU is for follow-up, and we do appreciate when listeners reach out. As always, stay safe out there.